All right, this problem is asking me to factor completely. Once again, whenever I factor, I first of all say, is there a GCF in greatest common factor to all the terms that are involved? In this problem, my coefficient, remember, is a 1. The biggest number that goes into both 1 and 16 is just 1. This term doesn't have any variables, so I couldn't look at the variables to pull anything out. So there is no GCF in this. The next thing I do whenever I have a factoring problem is I look at how many terms I have. And in this case, there's 2 terms. So I ask myself, the only thing that I have to factor with 2 terms, if there's no GCF, is a difference of 2 squares. So I first check, do I have a minus sign? Which I do. Is the first term a perfect square? So is there some number times itself that equals 1? There is 1. And is the exponent on the variable, is it an even number? Could I split it in half evenly? And in this case, it's 4, which is a perfect square. And then I look at the second part of the problem, so the second term, and I say, is this a perfect square? Is there some number times itself that'll equal just the 16? The minus was for the difference part. And there is 4 times 4 is 16, so for factoring a difference of 2 squares, which this is we start with 2 sets of parentheses. One of the parentheses is going to get a plus, and one of the parentheses is going to get a minus, because to get a minus sign when I'm foiling, I have to have one be positive, one be negative. Okay, then I'm splitting this up, and I like to think of this as like dividing like toys for children and stuff, and I need to have the exact same stuff in each set of pile of toys. So I have to first look at 1 times 1 is just 1, so I could put it here. I really don't need that. And I'm thinking, each set, I have 4 x's that I have to divide between these 2 parentheses. So 2 will go in here, and 2 will go in here. Notice this is the first thing. It's going to go in the front of each parentheses. So I still have 4 of my x's that I had from the problem, because there's 2 here and 2 here. And then the back part, I got to say what times itself was a 16. So I'm still splitting it up in the 2 parentheses, thinking with multiplication. So 16 was 4 times 4, so I put a 4 here and a 4 here. Now, the problem with factoring is knowing when you're done. So we look at everything again. There's 2 terms here. There wasn't a GCF because I already dealt with that at the very beginning. And I have to say, is this still a difference of 2 squares? This is a plus sign. It's not a minus. It's not a difference of 2 squares. So then I look at this set of parentheses, which is still 2 terms. It's a minus sign, so I have to check more. Is this a perfect square? Yes, because the coefficient's 1. The exponent is an even number. I could divide it into 2 piles. The 4 is a perfect square because it's 2 times 2. 2 times 2 is 4. So this one I have to go further with. It's not completely done. So what I'm going to do is, yet again, it's a difference of 2 squares. So I do 2 parentheses. 1 parenthesis gets a plus, 1 gets a minus, and I got to think of these 2 x's. I have to separate them into the 2 piles. So an x and an x. And 4 is 2 times 2. So a 2 goes in here and a 2 goes here. Don't forget, you still had this factor to start with. So just bring it down to your answer. And now double check with your new parentheses. Plus sign, it's not a difference of 2 squares. Minus sign could be, but this isn't a perfect square. Neither is the 2. So I'm completely done, and there's my answer.